Duchenne muscular dystrophy, a narrative on learning and memory. DMD is a disease that primarily affects young boys. It is a genetic disorder that results in the loss of an important membrane protein called dystrophin. When dystrophin is absent, you lose the entire dystrophin glycoprotein complex between the extracellular matrix and the sarcolemma membrane. As a result, the muscle membrane becomes unstable and vulnerable to lots of damage. One consequence of the loss of the DGC is that we lose the nNOS binding domain, which is important for localizing NO production to the sarcolemma membrane. Normally, NO is released from a contracting muscle, which allows for sufficient blood supply to the exercising muscle. However, in DMD individuals, NO is not properly released, resulting in the lack of blood flow to the exercising muscles. In general, boys with DMD have shortened lifespans. They progressively lose their ability to walk, develop respiratory complications, and have a decline in cardiac functioning. Now, did you know that some individuals with DMD also have cognitive defects? Although DMD is a type of muscular dystrophy, it has been shown that the loss of dystrophin may lead to altered synaptic plasticity and functioning in the brain. Boys with DMD have an increased risk for having problems with short-term memory, ADHD, autism spectrum disorder, and dyslexia. In a study by the Hinton Group, they showed that a group of boys with DMD scored significantly poor on comprehension and story recall when compared to their siblings.
So how does DMD, a disease that is characterized by muscle membrane instability, have an effect on cognitive processes such as memory? Let's take a closer look at how memory normally works. In general, memory can be considered a vast interconnection of synapses, and the hippocampus is the primary location in the brain for these memory processes. The brain is constantly changing and adapting. These neuronal connections can be strengthened through a process known as long-term potentiation. It serves as the primary biological mechanism to understanding how memory encoding and storage works. This is how LTP works. This image shows a presynaptic neuron and postsynaptic neuron in the hippocampus. Depolarization of the presynaptic neuron and synaptic vesicle release of glutamate reaches the AMPA and NMDA receptors on the postsynaptic neuron. The AMPA receptors are paired to ion channels that allow sodium to enter the neuron. Sodium entry results in depolarization of the postsynaptic neuron. The NMDA receptor also binds with glutamate, but it is the depolarization from the AMPA receptors that allows for the magnesium blocking the ion channel to withdraw from the NMDA ion channel. Without magnesium there is an influx of calcium ions. Calcium ions bind to calmodulin to form a complex that then sets off several biochemical reactions that make the synapse more efficient for an extended period. So how would DMD affect LTP? In the brain, there is normally a high density of dystrophin in the hippocampus and absence of dystrophin in other subcortical areas. In DMD, this brain dystrophin is missing in the neurons involved in LTP. The calcium homeostasis, an integral part of LTP, is altered, and the end result is memory deficits. This pathology suggests that memory impairment can be directly affected by the loss of dystrophin and cannot be simply attributed to the muscle pathology in DMD. But that is not to say that muscle pathology does not affect memory.
Another possible way DMD affects the brain is through lowered levels of nitric oxide released through nNOS receptors. Nitric oxide has a regulatory role in neurogenesis. Neurogenesis, the process of making new neurons, can occur throughout life. In the hippocampus, neuronal progenitor cells are able to differentiate into neurons. These adult-born neurons have higher flexibility and enhanced excitability. This aids in the creation of new synaptic networks necessary for memory encoding. In simpler terms, increased rates of neurogenesis is linked to increases in memory formation and consolidation. Nitric oxide affects neurogenesis by enhancing neuronal differentiation. Nitric oxide helps these cells to escape their immature proliferative state. Neuronal progenitor cells have not yet made connections with the local network and often die before becoming differentiated. Nitric oxide also allows these cells to continue on their path to becoming mature neurons and a part of the greater neuronal network. Although there are different sources of nitric oxide, or NO, throughout the body, a group of UCLA researchers identified that the muscle-specific nNOS in the sarcolemma affected the overall levels of NO available in the physically active mice. In the experiment, MDX mice, which is a model for DMD, and wild-type mice were both subjected to treadmill running. It was shown that physical activity significantly elevates NO levels systemically in wild-type mice, but not in MDX mice. These MDX mice had decreased overall levels of nitric oxide in the membrane and lower levels of NO as compared to wild-type. When the muscle-specific nNOS was overexpressed, it restored systemic NO levels in MDX mice. Results showed that increased NO levels in MDX mice also corrected hippocampal neurogenesis. Overall, loss of dystrophin in muscle indirectly affects the brain through a reduction of total nitric oxide levels in the body.
In summary, for DMD, memory is directly affected by the loss of dystrophin in the brain and indirectly affected by the reduction of total systemic NO. So how can we help boys with DMD that struggle with memory? Teachers and parents play a big role. Not all boys with DMD are the same, as each may struggle with memory in their own ways. Thus, teachers and parents must be able to provide special attention and personalized accommodations. Accommodations that can be made include breaking down information into smaller pieces that are easier to take in, giving extra time to process material or work on assignments, or providing summaries for lessons to promote retention of material. We hope that this narrative has expanded your understanding of DMD. Thanks for listening.